All you're doing is multiplying probability of each state of the road with the value that variable would obtain in that state. Doing this in Excel is not very difficult. Let's call this expected value and risk. We haven't done anything about the risk yet, but we will. So I have these states, probability, and value. Let's call this return. In this case, I have good, no, very good, good, bad, ugly. Probabilities are, these are my inputs. Make sure I remember that correctly. These probabilities have to add up to 1, so make sure that they do. Excel has a little summary bar here called status bar. You can actually see what that sum is without even separately calculating it. And the returns are 25%, 15%, 3%, negative 15%. Okay? And we can calculate expected value here. There's a function in Excel that we have used before, sum product. It calculates, if I give 2 columns, it calculates the product of the items in each row and adds them up, as the name of the function suggests. So it doesn't matter in which order I do it. Column B, column C. If you have more states, all you have to do is extend this, or less states, just make the probability of the other zeros. So I can actually extend this to a few states, and I'm going to make this all zeros. Or blanks, doesn't matter. So let's extend it until 16. What? Let's do it again. Okay. If I change the probability returns, it automatically updates itself. Now we're going to define a concept of risk. We will first define a concept called variance. We're not going to directly use that as a measure of risk. And standard deviation. We will use the Greek letter S for, and I'm gonna change the font of that symbol for the standard deviation. And variance is simply square of the standard deviation. Even though we define it in that way, we're gonna actually make a calculation for variance first, then we're gonna take its square root for its standard deviation. Let me write a general formula. I'm not gonna do the calculation here. So suppose you have n states of world with probabilities P1 through Pn, and returns of x1 through xn. Oh, by the way, we also use the Greek letter, Greek equivalent of the letters m for expected value. That's called mu, okay? Then variance is equal to, this is gonna sound very unnatural, and it is unnatural. Sum of these square deviations from the mean or the expected value multiplied by their probabilities. So I'm going to do P1 times x1 minus mu squared plus you do this for all of them. Nice thing about this is we can actually simplify this in a different way. This is also equal to P1 times x1 squared plus, for all of them, Pn times x n squared minus, oops, not that one. Let me get this. Minus square of the mean, which means to calculate the variance, I'm going to basically calculate the expected value of the square. So for each state of the road, I'm going to take probability, I'm going to multiply with the square of the term in that case, add them up. Turns out, so let me put in variance here. I can easily calculate the sum of probability weighted sum of these squares. Okay. Probability. In the sum product function, you're not limited to only two columns. If you have three columns, it's going to multiply the items in each row. Well, how do I calculate square of something? I multiply it with itself, right? So in the sum product, I'm going to take the return, and I'm going to take the return again. This actually gives me squares of the return. But of course, I want the variance, so I'm going to deduct minus the expected value squared. Variance does not add the same units as the returns. It's basically squared. So I'm going to leave this as a kind of number like that. Standard deviation, or let's call it ST_dev, is simply square root of this number.